Okay, student, today I'll start solid state. Solid state, what is solid actually? Solid means the chemical substances which are rigid, which are definite shape, definite volume, they have higher intermolecular forces, they are called solid. Now, the solid can be classified into two forms. One is crystalline solid, another one is amorphous solid. Crystalline solid and amorphous solid. What is crystalline solid? Crystalline solid means the solids which are true solids. They undergo a clean cleavage when cut. They have definite and regular arrangement of the constituent particles in space. They have a specific or sharp melting point. The crystalline solid have a sharp melting point like NaCl, quartz, all are crystalline solid. But on the other hand, the amorphous means they don't have any regular arrangement of the constituent particles. They have short order arrangement of particle. They melt over a certain range of temperature. They undergo irregular cleavage when cut. So there is a difference between crystalline and amorphous form. Crystalline means long range order. Amorphous means short range order. Crystalline have a sharp melting point. Amorphous, there is a range between melting point 200 to 300 or 200 to 250, whatever. And other difference and big difference is crystalline solids are anisotropic and amorphous solids are isotropic. What is anisotropic property? Anisotropic means, as you can see, the crystalline solids can be written as AB, AB, AB type. It's a regular arrangement, A after then B, then A, then B. But if you calculate to this in this direction, you'll get A and then B, then A, then B, a symmetrical distribution. But if you calculate to this one in this direction, then A, after that A, after that A, here B, B, B. So the physical property actually vary within the direction. So when the physical property varies or physical properties are different, whenever you calculate, whenever your reaction will be changed, that is anisotropic substances. Here physical property are different. But in this case, amorphous form, they are isotropic because there is a irregular arrangement, so their physical property will be same almost. So these crystalline solids are called also true solids and amorphous solids are called pseudo solid. It's looking like solid but it's not a solid. So basically in this chapter we will discuss about crystalline solids because crystalline solids is very important for class 12. The crystalline solid can be classified into four parts. You can see first part is molecular, then ionic, metallic and network or covalent. Molecular means the molecules like H2, Cl2, HCl, ammonia, H2O, whatever molecule is it. Polar, in molecular solid there are three classification. One is polar, non-polar and hydrogen bonded solid. Polar means obviously there is a polar bond like HCl, H plus Cl minus, ammonia because there is a lone pair. Non-polar like hydrogen, chlorine because there is no charge separation. Hydrogen bonded solid, the compound which forms hydrogen bonded solid. Okay, they conduct electricity but low electron conductivity it shows. Then ionic solid basically NaCl is a good example of ionic solid, but remember NaCl can conduct electricity in aqueous form only. not in solid form. Metallic solid, all the metal shows very good conductivity. That's why they are very good conductor, because it they loses the electrons from their outer shell and conduct electricity, like Fe, Ni, iron, nickel, aluminium, all are good conductor. And on the other hand, network or covalent solid means non-metal. When non-metal forms any solid, they are called network or covalent solid. Actually, network or covalent solid doesn't show any electricity or conductivity, but it is act as a good insulator. But one exception is there: diamond conduct electricity. So this is a exception. So in this portion we have to learn what is the difference between crystalline and amorphous solid, and the classification of crystalline solid, and the conductivity, how it changes according to their structure. Okay, next we have to discuss about crystals. What is crystal? Crystal means those substances which have a definite shape, definite arrangement, and sharp edge length, whatever. And example like sugar crystal, sodium chloride crystal, or a crystal. And in every crystal there is a cell, unit cell, because crystal lattice actually formed by unit cell. What is a unit cell? Unit cell means the smallest geometrical portion of the crystal lattice which can be used as repetitive unit to build up the whole crystal is called unit cell. Means if this is a crystal, then there is unit cell like this. There is a unit cell. There are 7 unit cell and 14 crystal lattice, which is also called various lattice. So 7 unit cell is there. First one is cubic unit cell, then tetragonal, orthorhombic, hexagonal, rhombohedral, monoclinic, and triclinic. 7 unit cell is there. Now look at this. There is in every crystal, basically in cubic crystal, there is 3 axes: x, y, and z axis. In cubic unit cell, we know A equal to B equal to C. So obviously A equal to B equal to C, then alpha equal to beta equal to gamma, because all the angles are equal. But in tetragonal unit cell, here A equal to B but B not equal to C. So obviously alpha equal to beta equal to gamma equal to 90 degree. For orthorhombic, A not equal to B not equal to C, alpha equal to beta equal to gamma equal to 90 degree. Angles are same, but alpha A equal to A not equal to B not equal to C. ABC here edge length. ABC all are called edge length. Hexagonal, A not equal to B not equal to C. Rhombohedral, A equal to B equal to C, and gamma equal to 120 degree. Monoclinic, there is A not equal to B not equal to C, alpha equal to gamma equal to 90, and beta not equal to 120. And triclinic, A not equal to B not equal to C, alpha not equal to B not equal to gamma not equal to 90. So this is the property of all the unit cell.